Hi everyone, this is Miss Afric, and we are going to start reviewing for finals with trigonometry. Okay, trigonometry is the first unit we did. Remember, if you have detailed questions, you should take a look back at some of the older videos or some of our old notes to try and help. This is just going to be a quick summary of the important stuff about trig. Okay, remember, problems in radians must have answers in radians, problems in degrees must have answers in degrees. And to confirm that you're doing right, doing that step correctly, check your mode on your calculator. Because remember, your calculator can be in degrees or radians. You have to tell it which one. Okay? So let's get started. Number 1, evaluate the 6 trigonometric functions of the angle theta. Remember, that's a theta. Okay, it's just like x. So the 6 trig functions, let's start there. The 6 trig functions would be sine of theta, cosine of theta, and tangent of theta. Those are the original 3. And then this year we talked more about their reciprocals. So cosecant of theta is the reciprocal of sine, secant of theta is the reciprocal of cosine, and cotangent of theta is the reciprocal of tangent. Alright? In order to evaluate those, there's this little thing we need called SOHCAHTOA. Alright, and that's going to help us to figure out which sides to put where. Alright, so in this triangle, here's my reference angle theta. I circle it. That makes this my opposite side, my hypotenuse, and looks like I'm missing my adjacent. Well, that's no problem, because in a right triangle, you can always use Pythagorean theorem. So x squared plus 2 squared equals my hypotenuse 5 squared. Alright, so solving this equation will get me my third side of the triangle. And it looks like we're going to have the square root of 21. Alright, I would simplify that, but it only breaks down into 7 and 3. Alright, and there are no doubles in there, and that's what we would need. Okay, so now I can start doing this. Sine of theta, sine is opposite over hypotenuse, so opposite is 2, hypotenuse is 5, so we got 2/5. Alright, now I'm going to jump to cosecant, because I know cosecant is the reciprocal of sine, so I can just flip it. 5 divided by 2. Alright, cosine's adjacent over hypotenuse, so that would be root 21 divided by 5. And I'm going to flip it for secant, so that's 5 divided by root 21. Now, you do have to rationalize, so I'm going to do that real quick. Alright, use your calculator if you need to for this denominator, because it should come out nicely, that's the point. Alright, root 21 times itself is just 21, and on top we have 5 root 21. So 5 root 21 divided by 21. Alright, tangent is opposite over adjacent, so we have 2 divided by root 21. Once again, we're going to rationalize, get the radical out of the denominator, and that's going to give me 2 root 21 divided by 21. And cotangent is the reciprocal. Now, I like to take the original and flip it, because that way I shouldn't have to rationalize twice. So root 21 divided by 2. And that's it. Alright, let's take a look at the next one. Number 2. Oops. There we go. Number 2 says find one positive angle and one negative angle coterminal with the given angle. Now, coterminal means they share a terminal side. The terminal side is where an angle ends. It's the side sticking out. Alright, so to figure out angles that are coterminal, all you need to do is go around the circle again. Either forwards, so adding 360, or backwards, so subtracting 360. Alright, and if we're in radians, like part B, we would add a full circle in radians. That's 2 pi, or subtract 2 pi. Alright, so for part A, I would take 330 degrees, and to get my positive coterminal angle, I'm going to add the circle. And that gives me 390. Nope, that's way off. It is 690, my fault. So that's my positive coterminal angle. And to get my negative one, I'm going to subtract. Alright, that gives me negative 30 degrees. Now, if you ever add or subtract, but you don't get the positive or negative angle you're looking for, just keep going, right? You can add as many circles or subtract as many circles as you need to. Alright, over here in part B, I'm going to do the same thing, but with 2 pi, because we're in radians now. Okay, you can do this on your calculator, but I think it's easier to just do it by hand. Alright, get a common denominator, multiply by 5. So that's going to turn into 10 pi divided by 5. And now I can just add them. So that means 13 pi divided by 5. And do the same thing to get my negative. I'm going to subtract 2 pi, which is actually 10 pi divided by 5. And that'll get me negative 7 pi over 5. So there's my negative coterminal angle. Alright, so coterminal, that means go around the circle again, pretty much. Alright, number 3. Number 3 is draw an angle with the given measure in standard position, and then find its reference angle. Alright, standard position means with an initial side and a terminal side and an arrow connecting them. So we'll see what that means when we do it. And a reference angle, remember, that's the angle between the terminal side, which is the side sticking out, and the x-axis. So let's try these. Alright, part A, we got 240 degrees. So to draw it, I start with my xy axis, and then I label what we call the quadrantal angles, the angles that go on each quadrant. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and lastly 360 degrees. Alright, so to draw this angle, I start with my initial side on the positive x-axis, the 0 degrees. Then my terminal side should go where 240 falls. So between 180 and 270. Right about there is 240. Alright, draw my arrow so I know which direction I'm moving in. And that's the angle in standard position. Alright, last part is my reference angle. Reference angle, remember, that would be this angle right here, x-axis and the terminal side. That is my reference angle. So that's the angle between 180 and 240. So I just subtract them. 240 minus 180. My reference angle will be 60 degrees. Boom, done. Alright, try it again for part B. Now, radians are a little trickier, but not too bad if you remember our tricks. Alright, 0 pi over 6. Remember, if a full circle is 2 pi, then just half the circle is 1 pi. But to keep the denominators the same, we just make it 6 pi over 6. And then again, the full circle is double that. So that would be 12 pi over 6. Then we just need the halfway points. So halfway between 0 and 6, that would be 3 pi over 6. And halfway between 6 and 12 is 9 pi over 6. Alright, and then we draw it the same way. Initial side on the positive x-axis. 11 pi over 6 is just a touch before 12 pi over 6, so, like right about here maybe. And then I'm going in the positive direction, so draw the arrow to show that. Remember, if it's a negative angle, you go backwards. Alright, then this right here is my reference angle between the terminal side and the x-axis. So my reference angle would be between 11 pi over 6, which is my actual angle, and 12 pi over 6, so I'll subtract. Alright, I always subtract bigger minus smaller. So for this one, my reference angle is pi over 6. And in case you don't remember, that's the same thing as 30 degrees. Alright, moving on. Number 6 says, given the ordered pair on the terminal side of an angle theta in standard position, find the 6 trig functions. So, whenever I give you a point, it should make the most sense to plot it first. Visualize it, right? Getting a picture of it is a lot easier. So negative 2, 1, 2, 3, 4, oops, a little taller, 5. So my point is right about here. And if that's on the terminal side, that means I should be drawing a terminal side to the origin. And from there I can get a triangle, a right triangle specifically. Alright, and not only do I have a triangle, but I know some of the sides, negative 2 and 5. Alright, then it's a 6 trig function, so that's kind of like what we did before. Sine theta, cosine theta, tangent theta, and the reciprocals. Cosecant theta, secant theta, and cotangent theta. Okay, the only extra piece here is that, once again, I'm missing a side. So I'm going to have to find it using Pythagorean theorem. 5 squared plus negative 2 squared equals x squared. Alright, so we get 25 plus 4, that's 29. So x is going to be root 29. That does not simplify. Alright, from there we fill in this part just like we did before. Alright, making sure we rationalize and things like that. Kind of just using SOHCAHTOA. Okay, so hopefully you can look back at that first problem if you need a reminder about how to finish this. Okay, so you would fill in the rest here, and that would be your final answer. Alright, go ahead and flip it over. We got some word problems to do, and then I'm going to do graphing in a different video, so we'll just do the word problems here. Okay, so solve the following applications. Show work and drawings. Number 7, a support cable from a radio tower. Alright, I see tower. So there is my tower. Alright, a support cable from a radio tower makes an angle of 56 degrees with the ground. So there must be a cable coming down here, and I can see my triangle start to form. It says it makes a 56 degree angle with the ground, and the cable is 250 feet long. That's this line I drew here. How far above the ground does it meet the tower? And then how far from the base of the tower is the cable anchored? So So x and y. Alright, let's solve for x first. Reference angle. So I got opposite, hypotenuse, and adjacent. So we'll set up a trig equation. Alright, if I'm solving for x first, I need the opposite side, and I know my hypotenuse. Well, O and H, that's sine. So we're going to do sine first. Sine of 56 degrees equals opposite divided by hypotenuse. And then to solve, we just multiply by 250. Alright. Now, if you type that into your calculator, the one thing you need to really make sure of is that you are in degree mode. Alright, take a look here. You got to match that mode. Alright, so we should be in degree mode. Then once we type that in, I trust you can do that yourself. We would get 207.26, what are we in? Feet. Alright, same thing for y, except now I need adjacent and hypotenuse, so that would be cosine. So we would do cosine of 56 degrees equals y divided by 250, and solve from there. Alright, we would get 139.8 feet. Okay. Now, if you have any questions on these problems that we're doing, please make sure you ask, write them down, and ask in class. Alright? I'm not going to do the second word problem because it's pretty much the same as this first one. So, again, write down any questions you have. If you're looking for unit circle or graphing, check a different video because those kind of take up a lot of time. I made a separate video for those. Alright? Write down any questions. See you in class.